Hey, all my dear students, very good morning. Welcome to yours Unacademy NEET English channel. Kids, do let me know. Just a second. Yes, my dear students. Yes. Why I got late? Let me tell you. See, kids, your Baba was making notes for you. See, and you see NCRT is also there. I welcome each and everyone to yours Unacademy channel. You can see number of things I was making. Not only one thing, two things, the complete NCERT. First of all, you can see, kids, the notes you can see, special cases you can see. I was busy in this. And this was just for you. It was not completed, kids. So I wanted to give you each and everything because this elimination holds a hell lot of weightage. First of all, I'm extremely sorry, kids. This is the first time that your Baba HSP got late. And this is only for you. The reason is my kids, my students, Vedha Janani, Mishkara, Shangita, Priyanka, first of all, everyone show me some fire in the chat section. Your Baba HSP is over here, kids. And I'm here with number of things that complete. Session will take 2 hours, not more than that. 2 hours. You can say 2 hours. And everyone, you have to make a promise that you have to be till the end. Because the session holds a hell lot of weightage, kids. You know that. It's your channel only. So everyone, smash the like buttons. I want you to see the best notes I should give you, kids. This session is not only the concept plus questions. Today I will show you the NCERT, whether it is of class 11th or class 12th, both the class 11th hydrocarbon and the class 12th alkyl halide, alcohol chapter, number of things, whatever is given in your NCERT, I am going to let you know, kids. So is everyone ready? Govinda Shwami, promise. Yes, you have to maintain the regularity and you have to show your attendance by smashing the like buttons. Now see, kids, without taking time, I am going to start elimination reaction. Elimination simply means, kids, something is eliminating out from the compound. For example, if I say, kids, that I'm having a basket. This basket is full of what? What can I keep, kids, in this basket? Let me keep some mangoes. 2, 3, 4 mangoes are there in this basket, and let me tell you 5, 6, 7, 8, 9, 10, 11, 12. Now there is no space left to keep the mangoes. Now, kids, this is fully saturated. This bag is full of mangoes. This bag got full, or the basket got full. Now, if I eliminate out, suppose if I say there were mangoes, there were some chikus, sapota, right? Sapota is chiku, and there were some other fruits like I say berries, some berries were there. And suppose from this solution, this basket, if I am going to take out this and this, one this and one this. If I take it out, from the basket, then what do you think it's? The basket will remain saturated, full, or it will become somewhat empty. Kids, do let me know if I'm going to take it out, these fruits from the basket, then that space will become vacant. That space will become vacant. Kids, are you getting my point? That space, definitely it is going to become vacant. Are you able to understand, kids? This is known as elimination, that saturated compound is becoming unsaturated, more unsaturated. sp3 hybridized carbon will change to sp2 hybridized or sp hybridized, or it will move through this. It is, you can say it is just a reverse of addition reaction. Nandini, welcome. Yeah. So you have to respond over there, kids. Whatever I'm telling you over here at the board, whatever you are not able to understand, let me know over there. If the answer you are getting, just tell me the answer in the chat section. Okay, kids, remember that. So elimination totally means that degree of unsaturation is getting increased. Now see, kids, this I've told you. Now E2 and E1. In the elimination, I will teach you E2 and E1, and it will be made up of dehydrohalogenation, dehalogenation, and dehydration. Means three things we are going to deal with. What are these? Dehydrohalogenation, dehalogenation, and dehydration. What is the meaning of all these three things? If I say the meaning, dehydrohalogenation means loss of HX. Dehalogenation means loss of X2. Dehydration means loss of water. Loss of water. These three reactions really, they are very, very important for your syllabus, for your NEET examination, for, I can say, even for JEE examination. These are really, really very, very important. So everyone, you have to apply your brain. Are you ready for that? You have to think yourself. You are not to sit like that. I will study over here and then later on I am going to complete. No, my dear students, that will not work. You have to apply your brain right now. Are you ready for that? Then it's okay. Otherwise, you can leave. Kids, if you are a fighter, if you are a real student, you have to think with your brain whatever I am writing, and you have to reply over there whatever you are getting, whether it is right or wrong. Then only it's your channel. Then only you are, yeah, very good. Vector Selva Kumari, yes, Mishkwara, everyone is ready, kids. That's really fantastic. Now see, I'm going to start with E2. E2 follows anti-pariplanar mechanism. See, kids, how much homework I did for you. See how much homework I did for you. For doing this question, we have to understand what is E2 follows anti-pariplanar mechanism. But before that, let me tell you what is alpha elimination, what is being beta elimination, what is E2 reaction, and what is E1 reaction. To understand this question, to understand all type of questions based on this, we should know what is E2, what is E1. Then only we are going to solve such type of questions. Now see, kids, to understand it, let me tell you something, then only you are going to understand it. Otherwise, you won't be able to understand it. See, so see, kids, elimination reactions, dehydrohalogenation. Dehydrohalogenation is mainly of two types. One is alpha elimination. Alpha elimination. Another one is beta elimination, alpha elimination and beta elimination. Now see what is the difference in between alpha elimination and beta elimination. In alpha elimination, there is only one example, chloroform CH, Cl, Cl, Cl plus KOH and heat. Now see kids, you know that you have to apply your brain. Chloroform is an organic compound, but KOH is having K positive, OH negative. This is having ionic bond. K positive, OH negative is ionic bond. So OH negative is a base, and base is always in need of acidic proton. So it will take away its proton. Now what charge this carbon is going to have? Negative charge. And this will convert into C negative, Cl, Cl, Cl. It will easily lose its proton. Why? Because it is stabilized by resonance. Now you will say how the resonance or how resonance? It is having extra electron in 2p and its 3d is vacant. It is having electrons in 3p but 3d is vacant. So it will lose its electron to 3d and it will do 2p pi 3d pi back bonding. 2p pi 3d pi back bonding. But still it is having charge. It is stabilized by back bonding. That's another thing. But still it is having charge. After some time, their K plus is unstable and there is negative charge. K plus will come and take away its chloride and it will convert into CCl2, dichlorocarbene. It's dichlorocarbene. It's looking like nucleophile, but it is having only 6 electrons. So it is electrophile. And kids, let me tell you, this will be responsible for 2 name reactions. What are these 2 name reactions? One is Reamer-Temer reaction, another one Karl-Mann reaction. Whenever I'm going to tell you about name reactions, that on Monday, I have kept a session for 100 questions, and these 100 questions definitely holds a hell lot of weightage. You will get in your examination from here only, in your NEET examination. So 100 NCERT based questions I will give you on Monday along with the tricks and concepts. Kids, that much I'm working hard for you kids, that whatever you are going to get in your NEET examination, you will get from there only, here only. Whatever I'm going to make new questions, totally NCERT based. Now see kids, this chlorine is lost from this carbon. The carbon which is attached with halogen is known as alpha carbon or first carbon. Same carbon has lost chlorine and same carbon has lost hydrogen. That's why this is known as one elimination, or you can say alpha elimination. Are you able to understand? Dichlorocarbon. Now see beta elimination. Maximum questions you will get from beta elimination only. See, this is hydrogen and this is halogen. Rest of the balances we can keep it like this. The carbon which is attached with halogen is known as alpha and this is known as beta. Can you understand which is alpha and which is beta? The carbon which is attached with halogen atom is known as alpha. Do remember it. And the adjacent carbon is known as beta carbon. Now KOH, the same KOH will come. K plus will take X negative from here. Along with the electron, this carbon will develop with charge. See, electrons are very, very important. If you can't see electron, if you can't visualize electron, if you can't put focus on electron, you won't be able to understand chemistry. So everyone, you have to focus on electron. It has lost electrons, so delta positive, and OH negative is in need of proton only. It has gained electrons, so negative. Negative positive will form another bond and you will get alkene over here. I hope that everyone is able to understand. One product, KX, another one, OH negative, H positive, water. So two type of molecules has converted into three types. So I would like to say delta S is positive, entropy is getting increased, and you know that Gibbs-Helmholtz equation. Gibbs-Helmholtz equation says delta G is equal to delta H minus T delta S. So for this reaction, temperature is important. Temperature, if you are going to increase temperature, then elimination yield means amount of product will also get increased. So remember that whenever you are going to deal with elimination reaction, temperature provides very important pathway towards elimination. So is everyone able to understand whatever I'm telling you, kids? Now see, we are going to focus on beta elimination. By beta elimination, beta is losing, or beta elimination is also known as 1,2 elimination. What is the meaning of 1,2 elimination? Kids, just try to understand. 1,2 elimination means this alpha carbon is known as first because it is attached with halogen, and this is second. So 1 is also losing and 2 is also losing. Here 1 elimination because both the atoms were lost by from the first carbon only. I hope this much is clear to all of you. Now see, we are going to see beta elimination in detail. Are you ready? Beta elimination in detail. Now beta elimination is mainly of two types, kids. Beta elimination is mainly of two types. What are these two types? One is E2 and one is E1. E2, E1. Now my dear students, this is first E2, this is second E1. If you have studied SN1 and SN2, my dear students, SN1 reaction and SN2 reaction, you have studied, then you know very well E2 reaction is bimolecular and it follows second order chemical kinetics. Second order chemical kinetics. Now my dear students, the second order chemical kinetics, this reaction will take place in single step elementary reaction, single step elementary reaction, my dear students, elementary reaction. And the reaction which takes place in single step, always remember, will not form an intermediate, will never form an intermediate. Without intermediate formation, this reaction will take place. No intermediate formation. And my dear friends, when no intermediate is formed, what do you think? Just do let me know. I'm coming towards your side. Whenever no intermediate is formed, that means rearrangement will take place or never take place. Write down the answer. Rearrangement will take place or not? No rearrangement, no ring expansion reaction. Simultaneous breaking and making of bond. Simultaneous breaking of bond and making of bond with transition state formation, with transition state formation. I hope my dear students, everyone is able to get it this much. Do let me know that everyone are able to understand this much. It is just like SN2 reaction. Only the difference is in SN2 reaction, substitution was taking place. Something was getting lost and something was gained by the carbon. But here, just the removal, just the removal, just the removal. Now, this is about E2 reaction. Now, let me talk about E1 reaction. See, kids, let me tell you something about E1 reaction. This was all about E2 reaction. Now, see, E2 reaction is single step. So what type of base is required? Just apply your brain. Strong base. The strong base can do anything in one step. So strong base is required. Here, weak base. Weak base plus heat. I have told you heat is always required. Here also, the strong base plus heat is required. There also, heat and weak base. Here, heat plus strong base. Clear? Now, even reaction follows. Yes, first order kinetics follows first order kinetics. Now, kids, this reaction takes place in more than one step. Complex reaction. This reaction is complex reaction. More than one step reaction. More than one step reaction. Now kids, whenever any reaction is taking place in more than one step, definitely intermediate will be formed, right? So rate of reaction will be directly proportional to stability of intermediate, and in this reaction, the intermediate's name is carbocation. That is carbocation. Carbocation is the intermediate. Now see kids, this much you have to keep it in your brain, then only you can understand this reaction. Are you ready, my dear students? Are you ready? Now see kids, first I will start with E2 and then I will proceed towards E1. But let me tell you the reagents for E2 and E1. E2 reagents, E1 reagents. Without reagents, you won't be able to understand anything. Reagents used. So dehydrohalogenation reaction. During dehydrohalogenation reaction, what reagents we are going to use? See, for E2 reaction, what type of reagent kits for E2? Strong base plus heat, like KOH, alcoholic plus heat. Now, number of times student must be thinking, sir, I have studied aqueous KOH is doing substitution and alcoholic KOH is doing elimination. What's the reason? I will let you know. But let me tell you, this you can use sodamide, NaNH2 plus heat. These two can be used. These are, now if you want to use, you can use RONA plus heat, ROK plus heat. All these are strong bases. Now for even reaction, what you are supposed to use? C2H5OH, aqueous or alcoholic, whatever you want to use, you can use ROH plus heat. These are weak bases, they are strong bases. I hope this much is very much clear to all of you. Now let's proceed the reason for alcoholic KOH. But before this, let me tell you alcoholic KOH. What's the difference between aqueous KOH and alcoholic KOH? See kids, the difference between alcoholic and aqueous KOH. KOH, aqueous, will do substitution reaction. KOH, alcoholic plus heat, will do elimination reaction. Now see, what's the reason behind it, kids? Why we are saying like this? Why they are going to play role of elimination and substitution in this way? So today you will come to know the reason behind it. If I break this KOH, K positive, OH negative, water, that aqueous, H positive, OH negative. You see, overall we have got only hydroxyl ion. Now, if I break this KOH, K positive, OH negative, and alcohol, suppose if I have got alcohol like this, CH3, CH3, CHOH, and if I'm going to break it, how it will break? CH3, CH3, H, O negative, and H positive. Now see, this K plus and this will combine together. Both of these combine together and they will ultimately form a compound like this or entity like this. Okay, now see kids, this is a little bit sterically hindered base. So difference in this is a small, so a small one will play a better role of nucleophile, mainly it will play a role of nucleophile, but this is sterically hindered, so very less role of nucleophile and mainly the main role of base. Its main role is base, its main role is nucleophile and little bit role of base. Now, when you are providing heat, heat supports what? Heat supports elimination. So when you are providing heat along with this, so little bit, only little bit nucleophile and mainly it is going to behave as base. So it is going to be responsible for elimination. I hope that everyone is able to understand, kids. Thank you, AK Wala Mas. Thank you, everyone. Now, have you got the difference between aqueous KOH and alcoholic KOH? If yes, show me the thumbs up. No one is going to let you know the difference between aqueous KOH and alcoholic KOH. Even in your NCERT, you're not going to get it. This is the burning question. Number of times, number of students were asking about it. So I've told you this. My dear students, do let me know. Are you happy? Now, let me tell you what is the mechanism, anti-pariplanar mechanism. What is the meaning of anti-pariplanar mechanism? What is the meaning of it? This now see kids, and why it is important. So I have to go back and let me tell you meaning of anti-pariplanar mechanism. Anti-pariplanar mechanism means, kids, let us suppose this is a compound and one halogen is coming towards observer side. Let us suppose this halogen is coming towards observer side. Can you feel? Wedge formula. This halogen is coming towards observer side and this hydrogen is going away from observer. Just if you focus over here, these two lines are being parallel lines. Let me show you these two lines. One line is this, another line is this. They are parallel to each other but anti-pariplanar. These two lines are opposite. Now let me draw rest of other lines as such, because carbon's valency is 4. So I have drawn 4 valency. Is it clear, kids? 4 valencies I have drawn. See, this carbon's 4 valency I have drawn like this. That carbon's 4 valency I have drawn like it. But we have to focus on these two atoms. Which two atoms, kids? These two atoms we have to focus over here and over here. Now, when KOH is going to attack on this, K positive, OH negative will come over here. Now they will start forming a bond with this. They will start forming a bond with this. This will form a bond with this. This will start forming a bond with this. And that will start forming a bond with this. Kids, till now everyone is able to understand. Now in the transition state, see what is going to happen. This is the most important point, and focus everyone over here. In the transition state, what is going to happen? The bond will start breaking because this X is forming, this X has started forming bond with K positive. So from here, the bond will start breaking. So see, this bond will start breaking and this bond will be getting formed. So now X has started forming bond with K plus. So from there the bond is getting weakening and here the bond is getting formed. Simultaneous breaking of bond and making of bond. This breaking of bond and making of bond has started. Now here also same thing is taking place. Breaking of bond and making of bond. Breaking of bond and making of bond. You have to understand, then only your life is going to become super easy. Now this is breaking of bond and there is making of bond. Now kids, when we are doing these things, what do you think? These bonds will remain as such, no effect on these bonds. Now kids, till now you are able to understand, because if you want to do a rank deciding question, if your dream is to get the best college, AIMS college, AIMS Delhi, other AIMS, the best rank for 700 marks, then you have to understand. Till now, see, this was your bonding molecular orbital. I would like to say BMO. And just opposite of BMO, there will be ABMO, anti-bonding molecular orbital. That will be empty. Empty means vacant, vacant. Now here, this is bonding molecular orbital full of electron. Carbon's electronegativity is 2.5 and this is 2.2. So electron is spending maximum time on this carbon only. So partial negative charge. Same thing, if this bond is getting broken up, that means its ABMO will become large. ABMO will becoming large, because when bonding molecular orbital is there, BMO must be having electron. ABMO is small. This is bigger one, that is smaller one. This is bigger one, that is smaller one. But once the bond has started breaking, the ABMO will start getting enlarged and this ABMO is vacant, empty. It is in need of electron, because this X is going along with electron. X is going along with electron. The K plus is taking electron of X. Have you everyone able to understand? So this is moving along with electrons. So here is delta positive charge and this H is going to leave electrons. So here is being delta negative charge. So there will also be beyond orbital. This orbital will be full of electron, 2 electrons. Now see, these are the boundary surface diagram. The electron will come in contact with this. See, if I draw real orbital, they will start touching to each other. So they will start touching to each other. This is real orbital. Now see, there is overlapping and you can say parallel overlapping, and this is the formation of pi bond. It is not right now exactly planar, it's like bent, little bit bent. So partial formation of pi bond is taking place over here. So simultaneous pi bond formation, simultaneous pi bond formation. Now kids, how many things are happening all together? How many things are happening? This sigma bond formation, this sigma bond formation and this pi bond formation. 2 sigma bonds are breaking and 1 pi bond is getting formed. 2 sigma bonds are getting broken up, 1 pi bond. That means it is endothermic reaction, and endothermic reactions needs more temperature or less temperature. Apply Le-Chatelier's principle, kids. What do you think according to Le-Chatelier principle? What Le-Chatelier principle says, for endothermic reaction, high temperature is good or low temperature is good. In the starting, I have told you delta S was positive. For this reaction, entropy was increasing and endothermic reaction. So if you apply Gibbs-Helmholtz equation, delta G is equal to delta H minus T delta S. So overall you can see high temperature is good. High temperature is good for this reaction. Overall, this summary we are getting. But see, this is the transition state. Now kids, do let me know what is the meaning of anti-pariplanar mechanism. Suppose if this X would have been on this side, if this X would have been on this side, then its BMO must be this side, then this ABMO would have been on this side, and if the ABMO would have been on this side, then is it possible that this ABMO can form bond with that BMO? No. So it's necessary that hydrogen and halogen should lie opposite to each other. If this is hydrogen, that should be halogen. They should lie anti and they should lie planar also. Why? Suppose if this hydrogen is lying on this side, then its ABMO, this ABMO is going up and its BMO must be going like this. This should be vertical, this should be horizontal. Then also pi bond formation would not have taken place, So the formation of pi bond in E2 reaction is only possible when halogen and hydrogen are anti to each other. Hydrogen and halogen must be anti to each other. One thing is anti and second thing parallel. They must be parallel as well as anti. Now this was the transition state. Now finally the product formation will be like this. This is your double bond. See kids, double bond formation has taken place and this is your alkene. This is KX. That is your water. Now we can do that question. If everyone is able to understand this thing, we can really understand the that question. See, here is your question. Now apply your brain. Before doing this question, my dear friends, we should know flying wedge and dash formula. What is the meaning of flying wedge and dash formula? Otherwise, we won't be able to do this question. Flying wedge and dash formula says that if we are provided with carbon, then one valency is coming towards observer side. This valency which is coming towards observer side, this is known as wedge. Now one valency is going away from observer. This is known as dash. That means away from observer, and two valencies lie in the plane of paper, whether they are given, shown or not shown. These two valencies, they lie in the plane of paper. These two lie in the plane of paper. These are the four valencies of carbon. Everyone, first of all, do let me know, are you able to understand? Whenever such type of things in my childhood, when I was able to see these, when I would be going to see these diagrams, I was shocked that I won't be able to do such type of question because I was scared of all these things, what these things are given. But kids, you will be able to understand. Now see, this bromine is coming towards observer side, right? Now which hydrogen, this is alpha, this is beta, this is beta. What do you think? Which hydrogen will eliminate out? Which hydrogen is going to eliminate out? Kids, do let me know which hydrogen will get eliminate out. Kids, do let me know, everyone. Towards observer, that means hydrogen must be away from observer. Now see kids, this methyl is going away. That means its hydrogen is coming towards observer because these two valencies are in the plane of paper and methyl is going away. That means its hydrogen is understood towards this bromine, towards this hydrogen towards observer. That means they are on same side. These two are in same side. This will not eliminate out because I have told you E2 reaction follows anti-pariplanar mechanism. Now see, this ethyl is coming towards observer side. These two valencies are in the plane of paper, two in the plane of paper, one towards observer side. That means its hydrogen is going away from observer. Am I right, kids? Now this bromine will go by taking electron. So here positive charge along with K positive and this OH negative, because these two are anti to each other, anti-pariplanar. So it will go along with this negative charge and negative positive will form a bond. Just to let me know everyone, you got it or not, kids? So this is going to be your product. This is going to be your product. Agreed everyone or not? Everyone agreed or not, kids? Do let me know. Everyone do let me know, are you agreed or not? This is the meaning of anti-pariplanar mechanism. Otherwise, you won't be able to do this question, kids. Do let me know first of all, you got it or not? Now, kids, if you are able to understand this one, just do let me know what should be your answer of this question. Kids, see how much hard efforts, best of efforts I added to give you such type of questions. Now what's your answer? Which will not show E2 reaction? Which will not show E2 reaction, kids? Fast, quick, everyone, I want to see your answer. Let me check it out. Who is going to give the correct answer, kids? You take it as a challenge. One kid has given the answer. Prabha Lakshmi, it's A. According to Prabha Lakshmi, it's A. Let's see what others they are going to give the answer. A. Nandini is also giving A. Ajay is asking for the time. Now see, kids, the correct answer is really fantastic. A is the correct answer. Now see how to do it. How to do it? See, this bromine is coming towards observer side. This bromine is coming towards observer side. That means it must be in need of hydrogen which is going away from you. This is away. That means hydrogen is coming towards observer side. So they are on same side. Can't go. This is going away. So hydrogen is towards observer side. Can't go. This is going. This is coming towards observer side. That means hydrogen is going away, 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 same side. This is going away. That means hydrogen is coming towards observer side. So these two are on same side. This is coming towards observer side. That means hydrogen is going away and this is also away. So they are on same side. That means in this reaction, all the hydrogen and halogens are on same side. That is same side, or I can say same side, or I can say sim. That means in this reactant there is no anti-hydrogen with respect to bromine. Kids, are you able to understand what I have written? Rest of all others, just see. Let me tell you this one. This bromine is coming towards observer side. This is also towards observer side. That means its hydrogen is away. So they are anti to each other. They are anti to each other. Let me tell you over here. This bromine is coming towards observer side. This is also towards observer side. That means hydrogen is going away. They are anti to each other. Here you can see this bromine is coming towards observer side. This is coming towards observer side. That means hydrogen is going away from you. It is also having anti-hydrogen, but this is not having anti-hydrogen. All hydrogens are syn. All hydrogens are syn. So in this reaction, no E2 reaction. This is the question for top 10 rank. Question for top 10 rank. Everyone is able to understand. I hope this is the question for top 10 rank. Question for top 10 rank. Everyone, you got it? Now, I will come to the NCERT. This was the hi-fi question. Only few students were able to give the correct answer, but no problem. Slowly, gradually, you will be able to understand. Now, let me move towards NCERT. Just see page number 380, NCERT. This is given in which NCERT? Class 11th NCERT. Class 11th. This is halogen attached to carbon is alpha. Another one is beta. Now, X can be chloride, bromide, iodide, but X cannot be equal to fluoride. Why? Because fluorine and carbon, they are 2p, 2p. This is also 2p. This is all 2p. Very strong bond. Very strong bond. But I will let you know, if fluorine is present in place of chlorine, bromine, iodine, then what will happen? That I will let you know about Hofmann product and Saytzeff product. Really the fantastic thing which holds a whole lot of weightage. I will let you know. But kids, see, this is your NCERT. See how much efforts I have added to it. You got alkene. Now 13.34. Now see kids. This is one more from class 11th. Let me tell you, this I have taken from class 11th NCERT part 2. Class 11th part 2. Now see how this reaction is taking place. There are two halogens, vicinal halide. Earlier, only one halogen was there. See, only one X was there. Then you got alkene. If two X are given over there, then you are getting alkyne. That means sp3 hybridized carbon. First it is getting changed to sp2 hybridized, and then sp hybridized this. In the starting only I have told you that how the degree of unsaturation. Now see kids, how this reaction is taking place. My focus will be over there. See kids, we are provided with CH2 Br. This is vicinal halide. Now if I am going to react it with alcoholic KOH, that means K positive will come over here, OH negative will come over here. This OH negative will take its proton, and this K positive will take its bromide negative. Now see what you are going to get. You will get positive charge at this place, you will get negative charge at this place. Now both together they are going to form a bond, and what you are going to get, you will get CHBr double bond CH2. Now my dear friends, this is the bromine, but this bromine is doing resonance with this compound, and due to resonance this single bond will develop partial double bond character. This single bond will become strong. Single bond will develop partial double bond character. Partial double bond character. Now my dear friends, if it is going to develop partial double bond character, that means this is vinylic atom and its name is vinyl bromide, and vinyl bromide cannot show reaction easily. So if I am going to add another alcoholic KOH, then too much heat will be required. So in place of alcoholic KOH, it's better to use NaNH2. So Why NCRT is going to use NaNH2? Let me tell you the chemistry of NaNH2. NaNH2 is being stronger base. Why NaNH2 is being a stronger base? See kids, if I have NH2 negative and I am having OH negative, just see, one is OH negative and one is NH2 negative. If I cannot compare who is being stronger base, what I should do, I will add proton to this, it will become ammonia, and I will add proton to this, it will become water. These are the conjugate acids. Now you know that very well. This is weaker acid because it is a base, weaker acid, and weaker acids form strong conjugate base, strong conjugate base. Its pKa is 15.5 at 25 degrees Celsius. Its pK is 35. Very, very weak acid, very, very strong base. Now, this Na plus will take away its bromide negative, and this NH2 negative will take away its proton negative, proton loss negative charge, bromide loss positive charge. In this way, you will get CH triple bond CH. Kids, see the reaction. This is explaining why first they have used KOH, alcoholic, plus heat will be given over there, and then they are using NaNH2. Now NaNH2 chemistry also I will tell you in detail because this is not sufficient. It's first of all, everyone, do let me know till now you are able to understand. Now see, if you're getting tired, if you're getting bored, if you're losing your energy, you're not able to understand, your dream college will go far away from everyone. And if you're doing hard work, your success is coming near to you. Kids, do let me know everyone is able to understand. Now on the basis of this, I'm going to give you the best question. But first of all, everyone, do let me know that till now, is it clear to each and everyone, my dear students? Wow. So everyone, I'm doing that much hard work. At least smash the like button, call your friends. You're not helping your Baba. You just think about the energy of your Baba also. How the Baba is going to maintain his energy. So everyone at least call one friend of yours. Now see kids. The question, what type of question the examiner is going to provide you, just see and focus over here. Suppose if the examiner has given you this compound CH2Br, first of all, it's not necessary that examiner is going to give you the structural formula. The examiner can even give you the name. Its name is ethylene bromide. Just let me know the name is right or wrong according to you. Ethylene bromide. It is saturated, but the name is ethylene. Just see, the compound is being saturated, but still the name is ethylene bromide. What do you think? This name is right or wrong? Everyone, do let me know. According to you, the name, whatever the name is given by me, written by me, is right or wrong? This name is right or wrong for this compound? This compound is having all sigma bonds, but they are writing ethylene bromide. It is correct? Then the answer is yes, absolutely, because this is journal name, and journal name has no meaning. You can say journal name, or you can say it is the trivial name, or you can say it is the common name. So don't apply your brain. This name is correct, and this is vicinal halide. Vicinal halide. Now kids, if the examiner is going to give you excess of NaNH2, if he is giving you NaNH2 in excess, then what should be the product? Is there anyone who can let me know what should be the product and how many moles of soda amide? Its name is soda amide. How many moles of soda amide will be utilized and what should be the product? Now just try to understand. Everyone, are you ready? Is everyone ready to solve this question? And just look over here how to do it. This is CHHBr, CHHBr. One NaNH2 will do the Na plus and the NH2 negative. NH2 negative will take away its proton negative charge and Na positive will take away bromide positive charge. Positive negative will form a bond. Then one more NaNH2 will come. Na plus will take away this bromide negative, one more positive charge. Their proton was gone, so negative and now positive, and this will take away bromide negative, and NH2 negative will take away its proton, so negative charge. Till now 2 moles of NaNH2 got consumed, or you got acetylene. Till now you have got acetylene. Now remember that, my dear students, acetylene's carbon is having 3.25 electronegativity, 3.25i, because it is being sp hybridized. So these two hydrogens are being acidic. Remember that it is having acidic hydrogens. Now I've told you soda amide is a base. So one NH2 negative will come and take away its proton. This will get negative charge. NH2 negative will come, it will take away its proton, it will get negative charge, and then finally you are going to get disodium acetylide, Na plus and C triple bond C negative, disodium acetylide. So it's this I have told you in my mind maps number of times. How many moles of NaNH2 got consumed? How many moles of NaNH2 got consumed? The answer is, Ashwin Krishna, do let me know. So the answer is finally 4 moles of NaNH2 got consumed. 4 equivalents of NaNH2 got consumed, right? This is your answer, and it has given disodium acetylide. Now, I hope that this is clear to all of you. Now, if I give you one question, that question is very, very important question. Question is given like this: CH3, CHBr, CH2, Br, and it is going to react with NaNH2 in excess. NaNH2 in excess. Soda amide plus heat in excess. What product you will get? And how many moles of NaNH2 will get consumed? This is your question. How many equivalents of NaNH2 will get consumed? Dear students, do let me know what's your answer. Now you must have to apply your brain. I'm waiting for your answer, kids. Apply your brain. Oh, great. I think Ajay has given answer right now. What I can see, Ajay, right now you have given the answer. If Ajay has given the answer right now, then I will say superb and I will clap for Ajay. Now 2. Oh, Ajay 3. 2, 3. What are you writing? 2 or 3, Ajay? Ajay, 2 or 3? What's your answer? Is the answer 2 or 3? Ajay is saying, I think it's 3. So 3 is the correct answer. See why. See everyone why. Na plus will come and take this bromide. One Na plus will come, take this bromide. One NH2 negative will come and take this proton. One NH2 negative will come and take away this proton. So 2 NaNH2, they have come together and they have formed CH3, C triple bond CH. Till now 2 NaNH2. Now it is having just one acidic hydrogen. It is not having two acidic hydrogens. So only one NaNH2 negative will come and you will get compound like this, gets CH3, C triple bond CNA. This will be answer. So answer is 3. 3 NaNH2 has been used. I hope everyone is able to understand till now. Kids, do let me know. Everyone, are you getting it? If you're not going to answer, whether the answer is right or the answer is wrong, it does not matter. What matters a lot, that is giving answer. Now kids, let's see. Where were we? Yeah, we have done till now. Now see kids. Are you able to see what is written over there? I think it's very small. It's very small. You won't be able to see. Now try to see. Now can you see? See, my NCERT was very old. The page got turned to be yellow. Now you can see some Alexander Saytzeff, also pronounced as Saytzeff. So two names, one Alexander Saytzeff and Saytzeff in 1875. That means they are the same name. They are the same name. Which two names? Which two names? One is Saytzeff, another one is Saytzeff. Both means same. First thing we have to understand, both means same. Can you keep this thing in your brain? Saytzeff and Saytzeff means same. These two names are same. What is the meaning of this name? Let's understand. They say that more substituted alkene. They talk about more substituted alkene. That's all. More substituted alkene. Saytzeff and Saytzeff means, because the name is same, they means more substituted alkene. The meaning of that is more substituted alkene. More substituted alkene. Now, it's not given over here. Let me tell you one more name. That is Hofmann. Another name is being Hofmann. The meaning of Hofmann is totally different from Saytzeff. The meaning of Hofmann product is less substituted alkene. Less substituted alkene. Less substituted alkene. Now you got two things, more substituted alkene and less substituted alkene. Hofmann product means less substituted alkene. Saytzeff product means more substituted, right? I will go slowly so that everyone can understand, kids. Okay, everyone, so that everyone can understand. Now let me focus on this reaction. I will show you this reaction later on. Whatever is given in NCERT, I will show you later on, or you can just see and then I'm going to explain. This is bromine. The carbon which is having bromine is alpha, and this is beta, and this is also beta. From here also hydrogen can eliminate, from here also. See, this alkene will form. and this alkene formed as 81% pentoene, and this alkene is just 19%. 19, two types of alkenes are formed. Now, this is given in NCERT. Let me explain NCERT. Are you ready? Everyone, you have to reply. Is everyone ready, kids? I'm going to explain this NCERT. Is everyone ready, kids? First of all, let me know that is everyone ready, kids? You have not to sit idle. You have to reply, kids. Very good. Now see, I'm going to explain it. Then only you can understand it. Now see, kids. Suppose I'm provided with a compound like this, CH3, CH2, CH, X, CH3. Just see this compound, and I'm telling you categorically, let me tell you, this X is chloride, bromide, or iodide, but cannot be fluoride. Here, what I am going to explain here right now, this X can't be fluoride. If X is fluoride, then something else is going to happen. Now, see, kids, this is your X attached to this carbon. This is alpha, this is beta, this is beta. Now, if I add alcoholic KOH to it, what is going to happen? Do let me know. KOH alcoholic, what it is going to do? KOH alcoholic and heat. So, the K plus will come over here, and K plus is interested in X as well as its electrons. So, it is going to get positive charge, delta positive charge. Now, this proton is on beta carbon, this proton is also on beta carbon. How the reaction is going to take place? Just see, once the reaction will move like this, this hydrogen will go CHBr, CH3. If this hydrogen is going along with OH negative and this Br is going along with K positive, we will get this product, this product, this product, because this was alpha, this was beta, and this is going to give you product like this. CH3, CH, double bond CH, CH3, this is butene. Now, another product, how you are going to get, see, one more molecule of that, I am going to take CH2, CHBr, and CH2H. This is also beta. This is alpha. This is beta. OH negative is going to take proton from here. This will get negative charge, and K positive is going to withdraw. Br negative, this will get positive. Positive and negative will form a bond. CH3, CH2, CH double bond CH2. Now I have got two types of products. Kids, see, just see to it. I got X, I got Y. Now how to find out which one is Saytzeff and which one is Hofmann product? Just see. If I put a line on this double bond, if I enclose, now see, one alkyl on this side and one alkyl on that side. On two sides, I have got alkyl. One alkyl I have got, and the second alkyl I have got. See, kids, two alkyls. So I will say this is di-substituted alkene. Di-substituted alkene. Now, same thing I am going to apply at this. Just take care what I am going to write. If I draw this box over here, now only one side alkyl is there. So what I will say, this is mono-substituted alkene. I would like to say that this is being your mono-substituted alkene, isn't it? So this is your mono-substituted alkene. Now kids, the ball is in your court. You have to tell me which one is Saytzeff and which one is Hofmann. Everyone, the X is more substituted because this is di-substituted. So this one is Saytzeff and that is Hofmann. Am I right or wrong, kids? Am I right or wrong, kids? Do let me know. Is it making any sense or not? Do let me know that. Yes. So Saytzeff product is major. Remember that. When I'm going to talk about even reaction, then 100% Saytzeff product will be major. But when I'm talking about E2 reaction, then in majority of the cases, Saytzeff product is major. I'm not saying in all the reactions Saytzeff is going to be the major. I will tell you 3 cases where Saytzeff or Hofmann can be the major, but generally Saytzeff product is major. So this is major. So this is about 80% and that is about 20%. No need to remember the percentage. It can be 81, 82, 90, but we have to remember that the Saytzeff product is going to be the major product. This is major and that is going to be the minor. Now kids, one more thing I would like to add. These two are isomers. What type of isomers? Here the double bond is on second position and there the double bond is on first position. What type of isomerism is there in these two compounds? They are structural isomers. They are structural isomers. One is formed in major amount, another one is formed in less amount. Whenever something is going to happen, and this will always happen in E2 reaction, more than one type of alkene will be formed and they are structural isomers. One will be in major amount and rest of others, whether 1, 2, 3 like that, they will be in minor amount. For this, there is one particular term in your organic chemistry, that is E2 reaction is regioselective. What is the word? Regio. Selective means one is more, others are less. Regio means related with constitutional isomerism, that is structural isomerism. So what I will say, E2 reaction is regioselective. What is the meaning of regioselective, kids? What is the meaning of regioselective? Do let me know, everyone. It's your turn. E2 reaction is regioselective. Regioselective. What is the meaning of this word regioselective? That means one structural isomer will be formed in major amount and rest as minor. This is just the meaning of regioselective. Now, I would like to add one more thing, that E2 reaction is stereoselective also. Now, what is the meaning of this? E2 reaction is stereoselective also. Now, see kids, really, this is very, very important point. E2 reaction is stereoselective also. That means we can say E2 reaction is regioselective as well as stereoselective. What is the meaning of stereoselective? It says that one of the stereoisomer will be in major amount, Now kids, let me talk about the same reaction once again. After considering these 2 points, let me deal with the same reaction once again and just see what new thing you are going to see, kids. What new thing you are going to see. Everyone, just focus over here, kids. The same reaction I am going to consider once again, and what new thing you are going to see, kids. If the examiner is going to ask how many types of products will be formed, question is how many types of products will be formed during this reaction? This is your question. How many types of products will be formed during this reaction? Which reaction, see, kids? The reaction is same reaction which I have told you or given you right now. CH3, CH2, CH, X, CH3 plus KOH, alcoholic heat, where X is equal to chloride, bromide or iodide. Now see, kids, what should be your answer? Do let me know, because I have explained each and everything. Now the ball is in your court and you have to explain me. What's your answer? Yes, kids. You have seen each and everything. Now you have to tell me what should be your answer. You will say answer is 2, but I will say answer is 3. Now you will get shocked why the answer is 3 and how the answer is 3. How the answer is 3. Kids, 2 products we have already formed. What were they? One was butene. Just tell me. One was butene. Another one was butanene. Butene and butanene, right? Now, he has not asked about the structural isomers. What he asked? How many types of products will be formed? This was the question. So whenever the question is given like this, that means all type of product. Now you consider this. It is dead for GI, cannot show GI, dead for GI, can't show GI, this can't show GI, can't show GI. But my dear student, this compound will show GI, active double bond. So this will exist as trans and cis. So one compound will be like this, trans butene. This is your trans butene. This is your cis butene, kids. Cis butene. And in less amount will be butanene. So these are the 3 products and these are the amounts, in what amount they will get formed, and this is the reaction actually, kids. Both of these are Saytzeff products. Both of these are being Saytzeff product. These are being Saytzeff, and that is being your Hofmann. I hope this much is clear, kids. This is crystal clear to all of you. Done and dusted. Is this done and dusted, kids? Now, Akanksha Singh, welcome. You got late today. Even I got late today. Now, Akanksha, very good, fantastic. Now, see, kids. Just do let me know if I give you this question. If I give you this question, then what should be your answer? CH3 Cl KOH alcoholic heat how many types of alkenes will you get, kids? How many types of alkenes? Then see, everyone, This chlorine is attached to this carbon. This carbon is known as alpha, this is known as beta, and this is also known as beta. Now we have to find out whether hydrogens are present, 1 valency, 2 valency, 3 valency. So one hydrogen is present, this can go, and here 2 hydrogens are present, any one can go. So just see, first of all we will get one alkene like this, and second alkene we will get like this. You have to just to let me know whether you are agreed or not with my answer. You are agreed or not? These two alkenes I am going to get. This is how much substituted. If I say this is the double bond, I enclose this double bond like this. So see, one side, two side, three side. This is tri-substituted. Tri-substituted. And I enclose this. Then one valency, another di-substituted. So this is being Saytzeff and that is being Hofmann, right? This is being your Saytzeff and that is being your Hofmann product. This is major, that is being minor, agreed. This is being major and that is being your minor, everyone agreed till now. Now, will you say that two products are formed or will you say more than two? What's your answer, kids? Two products, two alkenes or more than two? Two, only two or more than two? Everyone do let me know. Only two or more than two? Now, the answer is two only. See, cycloalkenes up to 7 membered. Cycloalkenes not more than 2, no. Cycloalkenes up to 7 membered can exist only in cis form with respect to their double bond. They cannot show GI. Cyclohexene cannot show GI because this is 6-membered ring. So better to write down one note, and this thing I have told you in geometrical isomerism. So remember that. Always keep this point in your brain. Cycloalkenes up to 7-membered cannot show GI with respect to double bond. So this is the note. You have to keep it in your brain. Then only you can solve the questions. Now kids, what I've told you, in even reaction always Saytzeff product is going to be the major, but in E2 reaction there are 3 special cases where Hofmann or Saytzeff, anyone can be major. And now we are going to reach to all those 3 cases, special 3 cases here. Saytzeff or Hofmann can be major depending on the type of case. Depending on the type of case, kids. Depending on the type of case, Saytzeff or Hofmann can be major. Now my dear students, maximum number of questions will be asked from here only. Examiner will ask number of questions from these cases only, and these are really very important cases. So is everyone ready to understand these cases, kids? Are you ready, kids? My dear students, do let me know. Sir, the case that must be major Hofmann. No, don't cram it. It requires brain. Kids, no need of cramming is required. That requires brain. I will let you know. Now see kids, let me tell you one by one. Are you ready? When fluorine is leaving group, so let's understand when fluorine is leaving group, what is going to happen? See everyone, CH3, CH2, CH, fluorine, fluorine is the special one, CH2H. Let me bring NaNH2 or alcoholic QH, doesn't matter, anything you can use, NaNH2 negative. And heating is required. Now see, this fluorine belongs to second period in the long form of periodic table. So it is 2p and carbon is already 2p. 2p bond is being stronger bond. This bond is very, very strong bond. Kids, let me tell you, this bond is very, very strong. Very, very strong bond. That means Na plus cannot eliminate out this fluorine. So NH2 negative will say one thing, you wait, let me take this proton. So NH2 negative is going to take proton from here. This carbon will develop partial negative charge and NH2 negative will take proton from here. This carbon will also develop negative charge. Now see, this carbon ion is 1 degree. This carbon ion is going to be 1 degree because this carbon is attached only with one carbon and this carbon is attached on both the sides with carbon. So this is going to be 2 degree. It's one is 2 degree carbon, one is 1 degree carbon. So if you talk about carbon ion stability, let me tell you, if there is no resonance, gets without resonance, which carbon ion is more stable? If I talk about the stability of carbon ion, you know very well which carbon ion is going to be more stable, kids. Stability of carbon ion. So stability of carbon ion is like this, that 1 degree carbon ion is maximum stable, then 2 degree, then 3 degree. 3 degree is least stable and 1 degree is most stable. If you know this thing from the GOC, then only you can able to understand this. Now, this carbon ion is more stable, so this carbon ion will get more formed. Once the carbon ion is formed, it will start donating electron to this carbon and this will also start donating electron to this carbon because carbon got negative charge. Now the electron flow will start toward this side and there will be electronic repulsion. Afterwards, this is going to break. I told you in E2 reaction, simultaneously positive and negative charge was formed because one side proton was eliminating out and one side halogen was eliminating out till now whatever we have studied. But in this case, as the fluorine's bond is very strong, what type of charge is first developed? In the starting, negative charge is developed because fluorine is not going to leave this carbon. This is strong bond. So proton is going eliminating out first. So negative charge is developed. So in the transition state, if I talk about the transition state is like this, CH3, CH, H negative charge and this NH2 negative has captured this proton and CH, F, CH2, H, this H has been captured by NH2 negative. So carbon ion. It's not carbon ion. I will not say it's carbon ion because in E2 reaction there is no intermediate formation. But yes, in the transition state, carbon ion is formed. Partial carbon ion. It's not pure carbon ion. So in the transition state, partial carbon ion is formed. In transition state, partial carbanion is formed, right kids? So rate of this reaction will be directly proportional to stability of carbanion in transition state, or we can say rate of this reaction will be directly proportional to the stability of partial carbanion. Are you able to understand? Don't cram it that in this reaction Hofmann product is going to be the major. In most of the books it is written only one example they are going to get this, and that's why students they start thinking that in this reaction always Hofmann is going to be the major product. No kids, Hofmann is not always going to be the major product. That depend on the type of case. So first of all, let me tell you very clearly, for this reaction, rate of reaction will be directly proportional to stability of partial carbanion. I hope this point is clear to all of you, that you will be able to keep this point always in your brain, kids. This is very, very important point. Will you be able to keep it in your brain, kids? Do let me know first of all, then I can move ahead. Kids, do let me know. Now, this carbanion is more stable. The more stable carbanion is more stable for product formation. So this will give you two types of product. This reaction is going to give you two types of product. One is CH3, CH double bond CH, CH3, and another one is CH3, CH2, CH double bond CH2. This is your Hofmann product. That one is your Saytzeff product. But kids, who is going to be the major product? Although this is unstable, but here this is going to be the major. 80% percentage no need to remember, but this is major, that is going to be the minor. Now kids, this example indicates that it's not always true that more stable product is going to be the formed as major product. This is, even though it is less stable, but here it is formed in major amount and this is formed in minor amount. Kids, clear to all of you? Is this example clear to each and everyone, my dear friends? Is this example clear to each and everyone? Now see, this is the only example which is available in most of the books, and that's why students think like that. Yes, in this case Hofmann is going to be the major product, but it's not actually like this. See, I'm going to give you one more example. You will start thinking that, wow sir, it's really fantastic thing. If I say I'm having this example, see kids, CH2 and let me give you what? Yes. So see kids, CH, F and CH3. Once again, I'm going to give you NaNH2, heat. Just see, once again, NH2 negative will come and it will take away this proton. This 1 degree carbanion will get formed and NH2 negative will come over here. See why? This is this carbon is alpha carbon, this is beta carbon, this is beta carbon. Now this is 2 degree carbanion, that is 1 degree carbanion, but this carbanion is stabilized by resonance. This carbanion is stabilized by, dear students, this carbanion is stabilized by resonance. Stabilized by resonance. Whenever the carbanion is stabilized by resonance, then the degree will not work, because resonance is the biggest thing. So this carbanion is stabilized by resonance, so that means this carbanion is being more stable. Now This is being more stable, gets more stable, more formed, more responsible for more stable, more formed, more responsible for what? More responsible for major product formation, more responsible for major product formation. Now kids, see which product is going to be the major over here. This product is going to be the major at this place, and this product is going to be the minor at this place. Now my dear students, you see this is a dye substituted. My really dear students, you can see this is being dye substituted, and this is being mono substituted. At my place there is heavy rain. Cherville, it's really, what to say, it's hailing, like hailing. Now I'm teaching for the last 30 minutes have been passed without AC. No AC is there. Why? Because power cut, because of heavy rain, my dear students. So you have to pay proper attention. Now this is dye substituted, that is mono substituted. That means this one is Saytzeff, or you can say Saytzeff, whatever you want to say, Saytzeff, Saytzeff. That is going to be a Hofmann product. Am I right, kids? Hofmann. So this time this is major because its carbanion was major and that is minor, my dear students. So if you are able to understand this example, let me tell you one thing very clearly, that when fluorine is leaving group, never see the stability of product, always see the stability of carbanion in transition state. What information we have got from this? For this type of reaction, never see the stability of product. Just see what? Just see what gets. Just focus on the stability of intermediate, stability of partial charge carbanion, partially formed carbanion. Product stability doesn't matter. Product stability doesn't matter. Product stability doesn't matter. Doesn't matter. My dear students, I hope this is clear to all of you. In one case, I have formed Hofmann as major. In another case, Saytzeff is formed as major. So let me tell you very clearly, categorically, this particular point, that just focus on stability of carbanion. Now see, we are going to deal with second case. This thing is very much clear to each and every one of you. So second is Hofmann exhaustive elimination. Hofmann exhaustive elimination. So are you ready for it? Now for Hofmann exhaustive elimination, this reaction is also that rate of reaction. Let me tell you, rate of reaction is directly proportional, once again, the stability of partially charged carbanion, partially charged carbanion in the transition state. Just like the previous example, I would like to say, here also you have to focus on partially charged or partially formed carbanion in the transition state. Now what is required? This reactions indication, or you can say how to determine this reaction, that is, reactant must be quaternary ammonium salt. For this reaction, reactant must be quaternary ammonium salt. Quaternary ammonium salts. And that quaternary ammonium salt with at least one beta hydrogen atom, one beta hydrogen atom, one beta hydrogen atom, plus strong base, plus heat, plus heat. These points you have to remember. Whenever you see quaternary ammonium salt, you have to think about He. He stands for Hofmann, exhaustive elimination. He. Now see, kids, everyone, see to it. Let me give you the basic example of this reaction. Basic, very basic. This is your nitrogen. Now the 4 valencies I am going to make, then only we will say it is being quaternary ammonium. See how many valencies I have added? 4. 4 valencies means nitrogen is having positive charge. One I have written methyl, another one also I have written methyl, one more methyl I have added, and here I am writing CH, CH2H, CH2H, or simply I can write CHH and CH3. Now this compound is having positive charge, that means some negative charge also be there. For example, I have enclosed it and I added X negative. Now this compound is electrically neutral, valency satisfied. Now generally you will get Ag2O heat. The base has Ag2O plus heat. Now see kids, everyone try to focus over here. This nitrogen attached to this carbon will be known as alpha, 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 beta, beta. So where we have to focus? Only on beta we have to focus. They all are being alpha. This is beta. So the base will come from this. The base will come and it will eliminate out proton, and this will get partial negative charge. Base will come and it will eliminate out this proton. It will get partial negative charge because this is 2p. That is also 2p. 2p bond is being a stable bond, so it will not, initially it is not going to break. So carbon partial negative, partial negative. This is your 1 degree carbanion because it is attached only with one carbon, and this is attached both sides. So this is being 2 degree carbanion. So 1 degree carbanion is being more stable, more formed, more responsible for product formation. Now see, once the carbanion is formed, they will start donating electron to this side. It will also start, they will donate to this. Then finally nitrogen will take its 2 electron and will go away. Now nitrogen has gone away. That means nitrogen's lone pair is like this: 1 methyl, 1 methyl, 1 methyl. We have got tertiary amine, and we will get 2 types of alkenes. One alkene like this, CH3, CH double bond CH, CH3, and another alkene like this, CH3, CH2, CH double bond CH2. Now kids, this was more formed, so this is more responsible for major product formation. So this is your major product, that is going to be your minor product. And kids, this is monosubstituted, so this is your Hofmann, and this is going to be your Saytzeff. Now by simply seeing one example, we cannot say in this reaction Hofmann is going to be the major. Mostly students, they see this only one example in the book. In most of the books, this is only one example given over there. So they start thinking that such type of quaternary ammonium salt is always going to produce Hofmann product as major. No, kids. Let me give you another example, and you will come to know that you have to understand the stability of carbon ion, then only you can get the answer. See, kids, the question is given like this. Just focus, kids. CH3, CH3, no, sorry, nitrogen, nitrogen, CH3, CH3, now CH2, and this is the phenyl attached to this. Phenyl is always considered phenyl. Whenever phenyl is there, always be aware of it. N positive, Cl negative, Ag2O heat, Ag2O heat. Now see, kids, this is nitrogen, this is alpha carbon, alpha carbon, alpha carbon, no beta carbon, leave them. This is alpha, this is beta, this is beta. So this is the point to be discussed. Now base will come, base will eliminate out this proton, you will get carbon ion 1 degree. Base will eliminate out this proton, carbon ion 2 degree, but this carbon ion is stabilized by resonance. So you cannot ignore resonance. Resonance is the most important thing. SBR, SBR full form is stabilized by resonance. So more stable, more fond, more responsible for product formation. So the type of product you will get this C6H5, CH double bond CH, CH3. This is going to be a major product, and plus C6H5, CH2, CH double bond CH2. This is going to be a minor product. Now you can see very clearly this is di-substituted alkene. You can see from here this side substitution, this side. So di-substituted, and this is, you can see only one side bigger group, but one side only. So mono substituted. Mono one is Hofmann, di one is Saytzeff. So the Saytzeff product is your major product. I hope that everyone is able to understand. So never cram it that in this reaction which is going to be the major, which is going to be the minor. Always consider the case, the carbon ion whose carbon ion is going to be more stable, that is going to form major product. I hope this much is clear to all of you. Let me know this much is clear. Now case number 3. Case number 3 is really fantastic case. Very, very bulky base. I too used to say this is chain's nature rule. According to Baba HSP will say it is chain's nature rule. Chain's nature rule. Chain snatcher. You know, number of people, they are snatching chains. Let me tell you the story of chain's nature rule. Then you will be able to understand. Somebody is having 2 kg chain, but it is very small. And somebody is bearing out only half kg chain, but it is very lengthy chain, very lengthy chain. Now, 2 ladies are walking on the road, the one having heavy chain, but it is small, and having some, what to say, scarf over there, scarf, you know, scarf, that cloth that is covering that chain. And another one is moving in dashing style, having half kg of chain, but having show off. He is doing show off. Now, kids, the chain's nature, definitely they would like to snatch 2 kg chain, because that is having more price. Nowadays it's very costly, means very costly, but they will snatch the chain of half kg only, means the chain which is easily available to snatch, to get snatched, that is half kg chain, because it is moving like a wave, it's moving, that show off. That's why parents, they say that don't have golden items like this in naked, always cover it up. Am I right, kids? Now see how it is going to apply over here. This is very, very bulky base, too much sterically hindered base. This base is being too much sterically hindered. Sterically hindered, kids. It's too much sterically hindered. Means bulky base, too much bulky base. Now, if I give you one example like this, CH3, CH3, H, CHX, CH2H, this base, potassium tertiary butoxide, it can be given like this also, CH3, whole thrice COK, or it can be written as potassium tertiary butoxide. Kids, sometimes they write in one style like TBUOK. It can be written like this also, like this, or like this. Now, heat. Now, for such a sterically hindered base, which proton can be eliminated out easily, because this is attached with X. So alpha carbon, this is beta carbon. We have to focus on beta hydrogens. This is sterically hindered, that is also sterically hindered. So for this base, it will be really very tough to eliminate out this base. This hydrogen can't be snatched easily. Can't be snatched easily. Why it can't be snatched easily? Can't be snatched easily. Why it can't be snatched easily? Because it is sterically hindered, and this is in naked. This is easily available proton, easily available proton. So this will easily go. So this will form major product. So major product will be like this, kids. This is going to be a major product, CH3, CH3, CH double bond CH2, and this is your Hofmann. So in this case, Hofmann will always be major. Hofmann will be major. So in this case, no need to think about anything. Hofmann will always be major. See, if I give you one question based on this, and number of times this question has been asked, kids. See, this question, number of times it has been asked. And those who don't know about this, they are going to get failed. CH3, X, CH3, 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 okay, heat. Now see, kids, this is halogen, alpha carbon, this is beta carbon, and this is also beta carbon. Which hydrogen is easily available? This yellow one or the red one? Which hydrogen is easily available, kids? See, that is on a steric hindrance. This is easily available. This hydrogen is being easily available, easily available, easily available hydrogen. So this was going to form major product. But kids, yes, yellow one, very good. 99% students, 99% students will eliminate out the red one. Let me tell you, because they will form Saytzeff product as major. But you have to take care that in this reaction, Hofmann product will be the major product. This is your Hofmann. This will be your major product, kids, during this reaction. And the Saytzeff product will be minor. Although Saytzeff product is being more stable, but will formed as minor, this will be your minor product. This will be your minor. That one is major, minor, major. I hope This point is very much clear to all of you kids. Now, if I give you one question like this, now the same question, if it is given like this, see, if the same question is given like this, but the reagents have been changed, see kids, question is same, once the reagent is given like this, second time reagent is given like this. Suppose if I give you NaNH2, heat, KOH, alcoholic, heat, and third reagent is given as CH3 whole thrice COK, heat. Now see kids, in the first two cases, definitely who is going to be the major? Everyone do let me know. In the first two cases, who is going to be the major? Definitely the major product will be Saytzeff, isn't it? Is your answer right? This only, this is going to be the major because this is being Saytzeff product. And in this case, the major product is going to be the Hofmann because this is being bulky base. So this is going to be the major. Am I right, kids? Are you going to mark this only or not? Everyone do let me know. If you are going to mark, then will you mark this only or not? Kids, do let me know. This is going to be the answer or not. Kids, I think you have got tired. Are you enjoying it? Everyone, Nandini Devi, R.R. Bichu, Miss Quera, Vedha Janani, kids, first of all, do let me know. Are you enjoying it? Be regular. Don't skip. Then only I will get energy. See, without AC, I'm teaching. Without AC. I think more than 1 hour or 1.5 hours has gone. Do you need break or should I continue? Do you need break or should I continue, kids? Do let me know. I will move according to you. If you need break, I will give you break. Nearly it's 2 hours. Yeah, just 2 minutes to 2 hours. If you need break, then I will give break. 10 minutes break. Should we take 10 minutes break? Should we take 10 minutes break, kids? Dehydrohalogenation. Dehydrohalogenation. Or continue? Yes, do let me know, kids. Should we continue or should we take 10 minutes break? What? Yes, continue. Okay. Let's continue. Oh, great, great, kids. Now do one thing, at least do one thing. You must be having your studious relatives or friends. At least call them, just join it. Let's make it huge, kids. Only 52 likes are there. If they are coming 52 more likes, at least it will go more than 100. Now see, kids. See what you can see. Is it visible to all of you? Is it visible to all of you? This is dehalogenation reaction. Same reaction once I have done. This acetylene I have formed through dehydrohalogenation. And now this is dehalogenation. See, kids. And this is given in class 11th NCERT. This is given in class, this is from class 11th NCERT. I took it from class 11th part 2 NCERT. I've taken this pic from there. See how much hard work I have done. Now, this is vicinal bromide and this is reacting with KOH and NaNH2. So This is not dehalogenation, wrong. It's not dehalogenation, it's wrong, kids. This pic should not be over here. This is dehydrohalogenation. So we have done it already, we have done it. It's not dehalogenation, it is dehydrohalogenation. It is dehydrohalogenation. So let's delete this one. Already we have done it. This is dehydrohalogenation. So what is dehalogenation? Let's come to the dehalogenation reaction. See, kids, dehalogenation reaction. Dehalogenation reaction means what? If I have got CH2Br, CH2Br, and if I react it with zinc, which reagent, kids? Zn. Now zinc will take away these two bromides. Zinc will take away these two bromides and zinc will get converted to ZnBr2. ZnBr2, and this will convert into alkene CH2 double bond CH2. Now you see, this is dehalogenation reaction. Both the bromides have eliminated out. So elimination is there, so heat will be there. Now kids, how this reaction must have proceeded, let's see. Let's see this CH2Br, this CH2Br, Br must be eliminating out. Then you will get compound like this, CH2Br, CH2 positive. Now you know very well, zinc is having standard oxidation potential that is positive, means zinc can easily undergo oxidation. This is very good. A reducing agent, very good. A reducing agent. A very good reducing agent will undergo oxidation easily. This point is clear to all of you. This is from physical chemistry, but easy point, common sense. Now it is going to give two electrons. These two electrons will go to this carbocation and this carbocation will change to carbanion, CH2Br, CH2 negative. Now this bromide will go and it will plus charge, and plus minus, it is going to form double bond. One pi bond will be there. Kids, this is the reaction and this is the mechanism. Now, in place of zinc, one more reagent can be used, that is NAI triacetone. NAI triacetone. Now, whenever I am going to write NAI triacetone, you will start thinking about Pinacol-pinacolone reaction. But in Pinacol-pinacolone reaction, X is only 1. That's why in place of X, I will take that place. That is a halogen exchange reaction. That is not elimination. There is NAI triacetone, but here you are having vicinal halide and heat is also there. Heat towards elimination, and two halogens are required to proceed with this reaction. Now, this reaction is really very important. See how and why this reaction is very important. Let me tell you, kids. Dehalogenation reaction is really very important. Why it is very important, let me tell you. See, kids, if I am having compound like this CH3, CHBr, CH3, this is very important reaction. You see, it is having two chiral carbons. This is one chiral carbon, this is another chiral carbon. So it is having two chiral carbon atoms, right, kids? Now, when this is undergoing dehalogenation, it will produce, definitely it is going to produce CH3, CH double bond CH, CH3. But $1 million question arises, this double bond is active, and it will show GI whether this compound is cis or trans. That is the million-dollar question. So the stereochemistry of this reaction is very, very important, and we should understand the stereochemistry of this reaction. So is everyone ready? It's this reaction. Why this reaction is very, very important? The stereochemistry plays an important role. But before moving towards stereochemistry, you must know Baba HSP strict. What was that? Your Baba HSP strict. Baba HSP strict. That is Tam Tushar Kar Sesam. Do you remember? Tam Tushar Kar CSM. Just here A means anti. A stands for anti. M stands for meso. C stands for cis. T stands for trans. R stands for racemic. Now, if you know these many things, these many points, then it will become easy to remember and to recall it. Now, see kids. Are you ready, kids? Is everyone ready? Kids, do let me know. Is everyone ready? Now, see kids, how the reaction is going to proceed. Now, if I take this compound, just see what will you call it. If I place bromine H CH3. Now this compound is having two chiral carbons, one chiral carbon, and along with this there is one plane of symmetry. If you can see the plane of symmetry, just try to understand this is the plane of symmetry. Everyone just focus over here. This is the plane passing through the middle of the compound, which is dividing it into two equal parts. And I would like to say this is the plane of symmetry present, and the plane of symmetry is present, then we'll call it meso compound. And when the meso compound is going to show anti-elimination reaction with zinc and heat, it will show anti-elimination reaction. Then complete it. What the examiner will ask, kids? Examiner will ask the product will be cis or trans. Just see how to find out the product. This is M, this is anti, so we'll say MAT, or we can say TAM. So trans alkene is going to be your product. Trans alkene will be your answer, kids. Only trans will get formed, no cis. Now kids, in E2 reaction, dehydrohalogenation, I said that was stereoselective as well as regioselective, because one was formed in major amount, other was formed in small amount. But here, this is the only product when you are provided with rajma chawal, rajma rice, and second one is pizza. If somebody is eating pizza more, less rajma rice, then we'll say he or she is selective. But if somebody is just having pizza only, not he or she is going to even touch the rajma rice, kidney bean rice, then what we'll say? He is or she is very, very specific. So this reaction is stereospecific. Why I am going to use word stereospecific? This is also related with stereochemistry, and that is also related with stereochemistry. So this reaction is stereospecific reaction. This reaction is what, kids? This reaction is stereospecific. This reaction is stereospecific. Everyone say stereospecific. Everyone say along with me, kids. Examiner will ask, definitely this reaction is stereospecific. . Oh my God. Once again, light has gone. This reaction is stereospecific. This reaction is stereospecific. Everyone say this reaction is stereospecific because this is also stereoisomer, that is also stereoisomer. So this reaction is stereospecific. Now see kids, if anyone is going to give you this question, just focus over here. If somebody is going to give you this one, so just see, what will you call it? Br over here, one Br at this place, two chiral carbons, it is optically active. And if I say H, Br, Br, H, CH3, CH3, it is also having two chiral carbons. So this we will say is a racemic mixture because both are being optically active, having chiral carbons without any plane of symmetry. No plane of symmetry is there. Racemic mixture. That was having plane of symmetry. This is not having plane of symmetry. No plane of symmetry. Racemic mixture. Now same anti-elimination is going to take place. Zinc and heat, anti-elimination. Don't apply your brain right now, otherwise you won't be able to understand anti-elimination. Just complete it. Ra. How will you complete it? Ra, RAC, or you can say CAR. That means RAC. Cis alkene is going to be the answer. Only cis alkene you are going to get, and that's why this reaction is also stereospecific. That means the two reactions are being stereospecific. This will be provided, this will be provided. You're supposed to find out this answer, or two things will be given. Third thing, you will be supposed to answer it out. It's got it. Everyone is able to understand till now. Now kids, this dehalogenation reaction I have told you with respect to vicinal. Now what will happen if gem halide is given? See kids, this is missing in your NCERT, and that's why I always say that NCERT writes in between the lines. So in case of gem halide, how the reaction will take place. In case of gem halide, how the reaction is going to take place. See kids, what do you mean by gem halide? Gem halide means when both the halogens are placed on the same carbon. This is the example of gem halide. They will give you a question like this: zinc and heat. What answer you will get? They will give you like this. Now kids, remember that this will be the type of Wurtz reaction. Wurtz Khalifa, it's not Wurtz Khalifa. Wurtz type of reaction will take place. Kids, always remember Wurtz type. I'm not saying Wurtz reaction. Wurtz type reaction will take place. Now, what happens in Wurtz reaction? Doubling will take place. So here also, doubling of compound will take place in this manner. CH, Br, 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 CH, CH3, zinc, 2 moles of zinc. Now what is going to happen, kids? It will eliminate out in this way. You can see what product you are going to get. You will get this type of product: CH3, CH double bond CH, CH3. Symmetrical alkene will be the answer. Symmetrical alkene will be your answer. Plus twice of ZnBr2. I hope that everyone is able to understand, kids. Do let me know. Everyone is able to understand this reaction. Is it clear to each and everyone? So dehydrohalogenation we have completed. Dehalogenation also we have completed along with stereochemistry. Only one thing is left, dehydration. And then this lecture will get completed, kids. Are you ready with the full of Josh, energy? Because permanency, perseverance, regularity, punctuality, these are the factors which we should have to get the best rank. Now, see, kids. Now we are moving towards our dehydration reaction. Dehydration. See, dehydration simply means loss of water. Dehydration means what? Loss of water. And without AC, too much loss of water, still already it's taking place, sweat is taking place. So loss of water. Water is very good living group. So this is dehydration. Now, this dehydration can take place in a single step or more than one step. If dehydration is going to take place in single step, my dear friends, see, it can take place in one step or more than one step. That means I'm moving towards what, kids? What I actually want to tell you, single step dehydration is non-acidic dehydration. That is E2 reaction, and that is non-acidic dehydration. Non-acidic dehydration. Now, kids, non-acidic dehydration will take place in the presence of reagents, and we have to keep these reagents in our brain. That is Al2O3 heat. This is known as alumina. Alumina. This is the most important thing. If this is not given, then they can give you sodium oxide, THO2 plus heat. If this is also not given, they may give you POCl3 and heat. But alumina is the most important thing. This is E2 reaction, single step reaction. Whenever we talk about E2 reaction, that means single step reaction, no rearrangement will take place. Single step reaction without rearrangement, without any rearrangement, without rearrangement. It's got it. Now, second one is acidic dehydration. That means even reaction. Even reaction, that is acidic dehydration. And for acidic dehydration, acidic thing is required. Now see, the reagents for this, the reagents, what reagents can be used? One is very well known, that is concentrated H2SO4 at 443 Kelvin, or this is for only ethyl alcohol, concentrated H2SO4 plus heat, better to say, or you can use concentrated H3PO4, H3PO4 plus heat, either this, or sometimes they can give you P4O10 aqueous. When you study inorganic chemistry, that also means H3PO4 only heat. So these are the reagent, and remember that whenever acidic dehydration is going to take place, it always proceeds with formation of intermediate, and intermediate formation gives an idea about, yes, what idea? That rearrangement may take place. So we'll proceed in more than one step, in more than one step. More than one step means intermediate will get formed. So the rate of reaction will be directly proportional to stability of carbocation. Stability of carbocation. Now see, kids, here rate of reaction directly proportional to stability of alkene and their carbocation. Now let's start. First, let me complete with E2 reaction, and then I will come to even reaction. I hope that till now It's clear to each and every one of you, my dear friends. Now see. Oh, this much is given. See, it's very small, but let me tell you, it's given in class 12th NCERT. This I have taken the pic from class 12, part 2, NCERT. I will come to this, but let me show you something. Temperature is the hero over here, see kids. For this reaction, temperature is the hero. If 443 Kelvin, you got ethene, and 413 Kelvin, you got ether. You just see high temperature elimination, low temperature substitution. It's high temperature elimination, low temperature substitution. Low temperature substitution. I will come to this and I will tell you this thing in detail. I will let you know. But first of all, let me tell you from my side so that you can understand each and everything properly. Now see kids. First, let me tell you non-acidic dehydration. Non-acidic dehydration. Let me take one example, CH3, CH3, H, CH2, CH2, OH, and I have added Al2O3 heat, Al2O3 and heat. So remember that this is single step reaction. What you're supposed to do, kids, the OH attached carbon is alpha carbon and adjacent to it is beta. Just remember what is alpha and what is beta. The carbon attached to OH or the OH attached carbon is alpha and adjacent of that is beta. This is beta. Now, from alpha, OH negative will eliminate out, will give positive charge on this carbon, and from beta proton will eliminate out negative, and negative positive will form a bond. This is snatching of water without any rearrangement. CH3, CH, CH3, CH, double bond CH2. This is plain reaction, simple reaction. No H plus, no carbocation formation. No H plus, so no carbocation formation. No carbocation formation means no rearrangement. No rearrangement. Now kids, if I give you another question, frequently asked question, this is known as neopentyl alcohol. Neopentyl alcohol. Now kids, Al2O3 heat is given. What do you think? What product will be formed? This is the question. What product, what type of product you will get? Now see kids, this carbon is alpha and this is beta, and this beta is having any hydrogen? No hydrogen, so no reaction. Remember that 99% student will do the rearrangement and they will find out the product with the rearrangement. Remember that no beta hydrogen, no reaction, no beta hydrogen, so no reaction, no E2 reaction. Kids, everyone got it? Are you able to understand this point? This point is really very, very important. Now, if I talk about acidic hydration, right now I told you non-acidic dehydration, but if I talk about acidic hydration, just see everyone, acidic hydration. Acidic hydration. This will follow E1 mechanism. E1 mechanism. If the same reaction I am going to give you over here, neopentyl alcohol, CH3, 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 CH2, OH plus concentrated H2SO4 and heat. Now here the reaction will take place. Here the reaction will definitely take place, kids. Why this reaction will take place over here? Just see. Apply your brain. You think like that you are forming the product and you are going to form the reactions product by yourself. This H2SO4 is more reactive. It will eliminate out proton, and that proton is in search of electrons. So directly the proton will come and attack on the lone pair. And once it is going to attack on the lone pair, this oxygen will lose its electron. And as soon as this is going to lose its electron, the oxygen will develop positive charge. Which charge, kids? Positive charge. Got it? Now, the oxygen got positive charge. Oxygen is saying, oh my God, I have developed positive charge. I can't tolerate this positive charge. When the charge is on carbon, carbonium ion. When the charge is on oxygen, we'll say oxonium ion. Its name is oxonium ion. Now, kids, oxygen is saying, I can't tolerate this positive charge. So we have to remove out water. Zupak. The water has gone. Zoom, zoom, zoom. The water is moving. Zupak, 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 zupak. So water is going. That means it has stolen the electron of carbon. Carbon got positive charge. Carbon developed positive charge. Now see what is going to happen. Now the carbon started crying. Oh my dear, what you have done? Where you have gone? You have stolen my electron. Oh, what should I do now? What should I do now? Now, whenever carbocation is formed, always think about rearrangement. Hey, let me have some rearrangement. Let me have some rearrangement. Carbocation form means think about rearrangement. Think about rearrangement. Think about rearrangement. Now, there should be 1,2-methyl shift. This methyl will take electron and it will shift to adjacent carbon. So, the more stable carbocation will more formed and more responsible for major product formation. See it, CH3, C positive, CH2, CH3, CH3. Now the carbon which is having positive charge, you can consider it to be the alpha, this beta, this beta, this beta, this beta and this beta, they are same, and this beta is being different. Let me take to another page, then I will form the product. Carbon, methyl, methyl and ethyl. Carbon with 2 methyl and 1 ethyl. See. Carbon positive along with 1 methyl. Another methyl, these are two same, then ethyl. Now kids, if we remove proton from here, then this carbon will develop negative charge and they will form a product like this. See, what product? CH3, C double bond CH2, CH2, CH3. If I remove this proton, then positive, negative, this product will get formed. See, what is this product name? CH3, CH3, double bond CH, CH3. So remember that in this reaction, Saytzeff product is always major product. Saytzeff product is always major product. This is tri-substituted. You see, this is being tri-substituted. This is being tri-substituted because it is having 3 alkyl groups. You can see 1, 2, 3 alkyl groups. So this is being tri-substituted. Saytzeff product major. So in even reaction, Saytzeff will always be major. Here Saytzeff will always be major, and this is just, see how much substituted, di substituted. So Hofmann product. Hofmann product. Can you see, kids? Everyone, are you able to understand? Now see, everyone, this is the dehydration, and here temperature plays very important role. Always see the role of temperature. Temperature is the hero in this particular reaction. Temperature role. Just see, kids, temperature's role. If I take ethyl alcohol and react with concentrated H2SO4, now see how many types of products will be formed. 1, 2, 3 and 4. These two green ones, they are really important. See, if the temperature is 443 Kelvin, then dehydration will take place and ethene is going to be the product, ethene plus water. And this reaction is being reversible. This reaction is being reversible. If you add water, according to Le principle, hydration will take place. Now, if the temperature is less, that is 413 Kelvin, 413 Kelvin, less temperature, then diethyl ether will be the product, C2H5O, C2H5. So this is known as Williamson's continuous etherification. It's not Williamson's synthesis. It is Williamson's continuous etherification. Williamson's continuous etherification. These two reactions are really very important, and I will tell you the mechanism also, because these reactions are given in our NCERT along with the mechanism. Kids, Akanksha, Miss Kura, very good. You are regular students, very punctual kids. I'm very happy to see you that still you are there. Very good, kids. Now, if the reaction is going to take place at 383 Kelvin, then the product will be C2H5HSO4, ethyl hydrogen sulfate. Ethyl hydrogen sulfate. Now, kids, if the reaction is going to take place at 0 degrees Celsius, then C2H5O positive H2 oxonium ion will be the product. Oxonium ion will be the product. Now, these two are not very important, but the right hand side, these two reactions are really very important. Now, kids, let's do some questions based on that, and then I will tell you Pinacol-pinacolone mechanism, and then this lecture, today's lecture, will get completed. Really, my dear students, RB Bichu, YT, Akanksha, Miss Guerra, fantastic students. Now, see, kids, let me give you some questions which are going to come in your examination, and these questions really holds a hell lot of weightage. But before that, before giving questions, let me explain the mechanism of both the reactions. So see, kids, mechanism. And you have to understand the mechanism by yourself, otherwise no one is going to help you if you're not putting your efforts. See, kids, this is ethyl alcohol, CH3, CH2OH, and H2SO4, you know, very famous for donating its proton. So H2SO4 will donate its proton, and proton will go attack over here. This we know very well. Now, what you are going to get? You will get CH3 CH2 O positive H2. Now, from here, two cases arises. As I have told you, if the low temperature is there, substitution, high temperature is there, generally elimination and substitution, like this. Low temperature generally substitution, high temperature generally elimination. So from here, two paths arises. One, path number 1, path number 2. If I put high temperature 443 Kelvin, that is high temperature for this reaction, definitely water will eliminate out. If water is getting eliminated out in this reaction, so we are going to get carbocation like this, CH3 and CH2 positive. So definitely sooner or later this proton will eliminate out and negative positive, we will get double bond. Alkene has taken place. Now, if the temperature is kept lower, 413 Kelvin, what is going to happen? Let's focus on this carbon. This carbon is attached with one hydrogen coming towards observer side, another hydrogen going away from observer, one methyl, and this is going to be the leaving group, O positive H2. Just consider SN2 reaction. SN2 reaction, do you remember? This is acting as leaving group, and another alcohol is going to provide its lone pair. It is going to attack on ABMO of it, ABMO. This is simultaneous breaking and making a bond, and this is your ABMO. ABMO is vacant and it is donating its lone pair to this. Simultaneous breaking and making of bond is taking place. This is your simultaneous breaking of bond and making of bond is taking place. So from this side it will leave, and this oxygen is going to provide electron to this. Inversion of configuration will take place. They will shift toward that side. This hydrogen will come toward this side. Inversion of configuration will take place. This hydrogen over here, this methyl at this place, and this ethyl alcohol, oxygen will develop positive charge, hydrogen, and this is being ethyl. Sooner or later, this proton will get lost and it will get its lone pair. And what type of product? You can say ET means ethyl, oxygen, and you can say this is also being ethyl only, CH2, CH3. This whole is known as Williamson's continuous etherification. This is known as what? Williamson's continuous etherification. Now kids, what type of question can be asked? What type of question? Sanjay Manipalli, sir, how to write the mock test freely in NEET Conquer batch? I will let you know that later on. Kids, right now very important topic is going on. So let me tell you what type of questions will come in your examination. See everyone. Question number 1. Arrange the following in decreasing order of dehydration rate. Arrange the following in decreasing order of rate of dehydration. Now see, what are the options given as? First option is given at tertiary butyl alcohol. Tertiary butyl alcohol. Second option is given as isopropyl alcohol. Third option is given as ethyl alcohol. Now, once they are going to react, What should be the answer? C, kids. In the first case, what carbocation we are going to get? In the first case, the carbocation, the second case, the carbocation, the third case, the carbocation will get like this. CH3, CH3, positive CH3. Second carbocation will get like this, CH3, C positive, CH3 and H. And third, we will get CH3, CH2 positive. What do you think, which carbocation is most stable? So the answer is, it is having 9 alpha hydrogen atoms. This is with 9 alpha hydrogen atoms. This is with 6 alpha hydrogen atoms. This is just with 3 alpha hydrogen atoms. So the stability of carbocations is like this order. This is the stability of carbocations. So this is the rate of reaction. So maximum rate will be of A, then B, then C. Even if you want to compare the product stability also, then you will see this is going to form this product, CH3, C double bond CH2, CH3 isobutylene, isobutylene. This will form product as propene, CH3 CH double bond CH2 propene, and this will form product as ethylene. So the stability of product is also very helpful in finding out the products. Very good. Everyone's answer is correct. Now second question. Everyone find out the answer of second question. See, kids. Oh, see, kids. First, let me show you this one. Just see. And let me know if you can see properly. Oh, ho, 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 ho. What happened to you? Now, kids, do let me know, is it visible to all of you? Can you see to it? Can you see to it, kids? Do let me know. Is it visible to all of you, kids? Now, this is tertiary alcohol. This is secondary alcohol. This is the NCERT class 12th. This I took it from class 12th NCERT. Part 2 NCERT alcohol chapter. This is your tertiary alcohol. This is your secondary alcohol. You can see clearly this is requiring just 20% phosphoric acid, and that is requiring 85% phosphoric acid. Why is this so? Because this carbocation is more stable and its carbocation is less stable. And you see the rate of reaction, dehydration, tertiary is maximum, then secondary, then primary. You can see I'm trying to show you each and everything from your NCERT also, kids. How much hard work. Shravan, what's your doubt? You can ask your doubt. Now, kids, see, this means this can easily undergo dehydration, and that cannot easily undergo dehydration, and that's why it is requiring more acid. Kids, just do let me know. Are you able to understand it? What is the meaning of this? When somebody is requiring more concentrated acid, that means it cannot show reaction easily. That's why it is requiring more concentrated acid, and this is requiring less concentrated. Even see the temperature also, 440 Kelvin and 358 Kelvin. Now you will say, sir, you told us only 443 Kelvin. That temperature was ethyl alcohol only. For other alcohols, temperature, no need to remember the temperature. Let me tell you one more thing. Let me tell you. This would be your major doubt. This would be your major doubt, but let me tell you clearly, kids. If I write over here, this temperature is important only for ethyl alcohol because no other bigger alcohol is going to form ether. Only ethyl alcohol is going to form both alkene as well as ether. Other alcohols will not form ether. That's why let me make you this point very clear. Otherwise, you will always remain confused. Get see to it. Very, very important thing I'm going to tell you over here. Just focus over here, kids. This is the most important point. Temperature is important only for ethyl alcohol. Only for, I'm not saying temperature, particular temperature, that specific temperature. I'm not saying only temperature. I'm talking about specific temperature. Specific temperature is important only for ethyl alcohol. Now, why only for ethyl alcohol? Because ethyl alcohol is the only alcohol which forms both alkene and ether as well as ether. Rest of all other alcohols, rest of all higher alcohols will give alkene only. So at any temperature they will form alkenes. So any temperature. So at any room or higher temperature will be suitable for them. Now kids, let me come back to what I was telling you. Now I was telling you this thing. So here you can see very clearly 440 Kelvin is given over there. So it will work because no specific temperature. 358 Kelvin is given over there. So it is not going to affect because the particular amount of temperature at 443 Kelvin that is going to form alkene and 413 Kelvin that is going to form ether, that was required only for ethyl alcohol. For rest of other alcohols, no particular temperature requirement is there. Now see question number 2. Once again in the decreasing order of dehydration. Now see kids, this is your first alcohol. This is your first alcohol. This is your second alcohol. This is your third alcohol. And this is your fourth alcohol. What do you think? What should be the order of dehydration, rate of dehydration? The 4 alcohols I have given you kids. So see how to do it. And I think that your answer is going to be wrong. The first time, whatever the answer you are going to give, that will be wrong. And after that, I will let you know where the mistake is done by you. And not only by you, 99% student, they do the same mistake. I will let you know. First of all, you give me the answer. Then I will tell you what mistake is done by you kids. DCBA. DCBA. Oh my God. Miss Guerra, in the first attempt only, Kanksha is giving A, B, C, D. It's decreasing order. Let me write down decreasing order. Otherwise, both of you are giving the correct answer. Decreasing order of rate of dehydration. Decreasing order for rate of dehydration. Now, tell me your answer. Decreasing order for rate of dehydration, DCBA. So kids, your answer is absolutely correct. I don't know how you have given the answer, but yes, it's wonderful answer given by you in the first attempt only. This is going to form a carbocation, this is going to form a carbocation, this is going to form a carbocation, and this is going to form a carbocation, and the carbocations will look like this. Its carbocation is resonance stabilized. Its carbocation is resonance stabilized because it is doing resonance from here to here. Stabilized by resonance, most stable carbocation. Its carbocation is 3 degree. 3 degree carbocation. Its carbocation is going to be 2 degree. No. Its carbocation is going to be 1 degree, but right now you have given the correct answer, but sometime you may miss it. You will do the hydride shift, but remember that never compare the ease of dehydration or ease of reaction by doing rearrangement. At the time of comparison of ease of reaction, whatever the carbocation is formed for the first time, immediately you have to compare with that only. Never do the comparison after the rearrangement. But kids, what is this? Only 54 likes. Smash the like buttons, everyone. I want to see this likes up to 60 kids. Now see what product is it is going to form, what product, but definitely its product will be the most stable, and that is benzene. That is the driving force for its stability. Its product will be benzene, the most stable product. This is going to be the, so the correct answer is D, C, B, A. This is your answer, and you are right. You are right, kids. Everyone is correct. Now, kids, full and final, we are going to approach towards the last thing, that is your Pinacol-pinacolone rearrangement, the very, very important thing. Is everyone ready for Pinacol-pinacolone rearrangement, kids? Is everyone ready for the Pinacol-pinacolone rearrangement, kids? Yes, do let me know. Is everyone ready for the Pinacol-pinacolone rearrangement? Do let me know. Is everyone ready for the Pinacol-pinacolone rearrangement, kids? Do let me know. I'm waiting for your answer. I'm going to move towards Pinacol-pinacolone rearrangement. Yes, everyone is ready. That's really fantastic. Pinacolone rearrangement. First of all, we have to understand what is pinacol. Pinacol is this type of compound. OH, OH, R, R, R. These R can be same or different. R may be same or different, doesn't matter. But what matters a lot is the OH should be on adjacent carbon. This is pinacol, and the smallest pinacol, if we want to write a smallest pinacol, then we have to place 4 hydrogens. This is the smallest pinacol. This is being the smallest pinacol, kids. Now you have to do one thing. Don't think like that. Whatever I'm going to tell you, you have to see to that. You just apply your brain and try to find out the answer so that you can form any product by yourself, just like solution of maths, right? No need to cram. Okay, right, kids? Yeah, see. If I take a smallest pinacol, that is your CH2OH, CH2OH, and I put H2SO4 on it, add H2SO4 to it. I have added H2SO4. Now kids, just think by yourself. Now today we will make the product. We are not going to learn the product. We are going to make the product, kids. Now I need your support. Just do let me know what is going to happen. This H2SO4 will release its proton, right? Just like bullet from the gun. When you are striking the gun's trigger, bullet will come out. So H2SO4 is just like bullet and gun. H plus is going to come out, and that H plus will attack either the lone pair of this oxygen or the lone pair of this oxygen. So it is going to attack, ding 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 ding, show. That's attacked. Now after the attack, what you are going to get? CH2OH, CH2O positive H2. Now see, oxygen has developed positive charge. What oxygen is going to say? Oh my dear, I can't tolerate this positive charge. When oxygen is saying this, oxonium ion is formed, and this is saying that I can't tolerate this positive charge, then what we will say? We will say, okay dear, eliminate out water. Eliminate out water. Water is very good leaving group, so water will eliminate out. Then what you are going to get? You will get compound like this. Now kids, this is the turning point. See why this is going to be the turning point. Here only people are going to do mistake. Most often the number of students, the most of the students, the majority of the students, they are going to make mistake over here. Now this is the carbocation. Let me tell you, this is, let us suppose, carbocation X. Now whenever the carbocation is formed, think about rearrangement. I'm telling you, just think about rearrangement. If with the rearrangement you are going to get more stable carbocation, then only the rearrangement will take place, otherwise it's not. Now tell me, if the hydride shift is going to take place, then you are going to get more stable carbocation. Right now this carbocation is more stable. That is the point to be noted, my lord. Just everyone do let me know, after rearrangement the carbocation is going to form, that is more stable, or right now the carbocation which is already present, that is more stable? This is the $1 million question, kids. This Y carbocation is more stable or the X carbocation is more stable? Which carbocation is more stable? You have to answer it, kids. Then only you can reach up to the product. This is $1 million question, that which carbocation out of X and Y is being more stable. Everyone, do let me know. Now it's your turn. I'm waiting for your answer. It's your turn, kids. Do let me know which carbocation is more stable. So definitely 99% students will say X is being more stable, but X is not more stable. Y is being more stable. See, this oxygen is having lone pair on 2p. 2p oxygen belongs to second period, and this is also 2p. 2p pi, 2p pi, excellent back bonding. 2p pi, 2p pi, excellent back bonding. After some time, so this carbocation is more stable, hence declared is to be more stable and thus to be less stable. So reaction is moving toward this side. After some time, HSO4 negative will come and take away this proton. Loss of proton, negative positive, bond formation will take place. So the answer is CH double bond O CH3. This is your answer, kids. Now, if you are able to understand, wow, Akanksha, very good. Why is being more stable? Now, if you are able to understand, then you can do any question within fraction of second. See, kids, let me give you 2, 3, all type of questions, whatever the examiner can ask. Let me give you all type of questions. First question, CH3 OH CH3. First, you need your pen and copy to solve this question, and then you will be able to do in the air. Practice makes everyone perfect. Kids, first take your pen and copy, try to do it, and then once if you are able to understand it, then you will be able to do it in your brain only. See, kids, H2SO4 will eliminate out proton. That proton will come and attack on the lone pair of oxygen. Ting, 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 ting. It will form oxonium ion. Oxonium ions, water will eliminate out. You will get carbocation. Till now, is it okay in your brain? You can do this chemistry, this much of chemistry in the air, that carbocation has been formed. Whenever the carbocation is formed, just think about rearrangement. So, the rearrangement will take place 1,2 methyl shift. Ting, ting, ting. 1,2 methyl shift has taken place. Now 1,2 methyl shift. What you are going to get? CH3, C positive, OH, C, Me means CH3, Me means CH3, Me means CH3. This H plus will eliminate out, and the final answer will be CH3, C double bond O, CH3, CH3, CH3. This is going to be answer. Now, in your brain, you must be getting one question. That's if unsymmetrical alcohols, that pinacols are given, then what should be the answer? Let's take unsymmetrical. In case of unsymmetrical, what should be the answer? Let's see. If unsymmetrical has been provided, suppose it is given like this. CH3, H3, OH, CH3, OH and H. Now kids, the H2SO4 will donate its proton. Definitely the proton will come and attack on both the sides. But what do you think, which is going to provide more stable carbocation? Its carbocation will be 2 degree and its carbocation will be 3 degrees. So definitely proton will eliminate out water from here, because this is going to provide more stable carbocation. Not able to understand? Let me write down. Its carbocation will be like this. And if you're forming this carbocation, then this should be like this. So which one is more stable? Let us say this one is M, that is N. Which is more stable? M is more stable or N? Definitely M is more stable. So this will be your major product, not the product. Intermediate will be more stable. So major. Now, which shifting will take place? If methyl shift is taking place, not the stability will not come. So 1,2 hydride shift will take place, and you are going to get this CH3 H C positive CH3OH, and finally your answer for the major product will be like this: CH3 H C double bond O CH3. Now I will take just 5 minutes, kids. 5 more minutes. Let me tell you this pinacol in the cyclic compound, and then I will tell you the trick also. First the in-depth knowledge and then the trick, because we don't know which one is going to work at what time. See, kids, if the compound is given like this, this is your pinacol. Now H2SO4 is added. What answer you are going to get? Now, kids, for this we should know that 6-membered ring is being more stable, then 5, then 7, right? Is this point clear to all of you, that stability of rings is like this: 6, then 5, then 7. In most of the cases, the stability order is like this. So first of all, when the H2SO4 is going to attack, you will get oxonium ion. So let me form the oxonium ion first without any problem. We will get this, OH and positive charge at this place. Till now it's very clear to all of you. It's very easy till now, right? Now this 4-membered ring will say that let's do the expansion. 4-membered ring will try to become 5-membered. Now see how the ring expansion. Then I will tell you the short trick also. This will try to become 5-membered. So it will take electron. This carbon will develop negative charge, and this carbon will develop positive charge. Till now it's okay. Is it clear? Now see, from here, this side, the bond is getting broken up, and simultaneously it is going to form bond with this carbon. So see how the ring expansion is going to take place. Let's see. This will remain of 4-membered only, no problem. This will remain as the bond only, no problem. This will remain the OH only, no problem. Till now nothing is like that, not the problematic thing. Now this is going like this, so it will go like this, it will go like this, it will go like this, and it's the new bond formation. See, kids, right now this is the new bond formation has taken place. You can see very clearly right now this is the new bond formation which has taken place. Now positive and HSO4 negative will come and take away its proton. HSO4 negative will take away its proton, and it will develop negative positive. The bond formation has taken place, and this is going to be a product. You can see clearly, kids. I don't think that there is any problem. This is 4-membered ring, and let me tell you, this was the ring, this was the ring, this was the ring, this was the ring, and this is 5-membered ring, and this is the product formation. You can see clearly this is the product formation. Is it clear to all of you? It must have taken at least 4 minutes. Your teacher has taken 4 minutes. 4 carbons over here. 4 carbons over here. Total 8 carbons. And in this also, this is common carbon. So total 8 carbons. No problem. Carbons are conserved. Now, how many of you want the trick? Kids, how many of you want to solve this question by the trick? HSP Baba's trick. Now see kids, I'm going to give you the trick to do this question. And not only this question, all the questions. The trick is applicable to all the questions. See, this was your question, isn't it? This was your question, right? So total 8 carbons are there. What you are supposed to do, kids? Make one ring of 4 carbon only. Make one ring of 4 carbon only. And another ring of 5 carbon. But a spiro compound. You are supposed to make a spiro compound like this. You are supposed to make a spiro compound like this. This carbon is common and the bigger ring just at this point. See which point? The crossover road. Crossover road, you know, which is having 4 directions. The bigger ring adjacent to this crossover road place double bond O. That's the trick. This is HSP Baba's trick, kids. Are you able to understand? Your HSP Baba magical chemistry grows trick. Are you able to understand? Now kids, you will say, sir, do one more question on the basis of this trick. Let me tell you another question. See kids, one more question. Suppose if the question is provided like this. This is the question. You try yourself. Let's see whether the trick is working or not for you kids. So 5 carbon, 5 carbon. Total how many carbons? 10 carbons. 5 carbons, 5 carbons. No need to even count the carbon. 5, 5. Just make one ring of 5 carbons. One ring of 5 carbons. Another ring of 6 carbon atoms. See the spiro compound, and over here put double bond O. Are you able to get? Now see kids, you must be thinking that if we are going to get unsymmetrical rings, no problem, unsymmetrical rings. This is being unsymmetrical ring, so this wants to expand. So what should we answer? Let's manage this ring to be of 6 and this also of 6. Now 6 and 5 11. There are also 11 because this carbon is common and place over here double bond O. So these are the answers kids. Now after this I'm going to give you one rank deciding question, and everyone you have to give the answer in the chat on the comment section. Okay, this is going to be a homework question. If this is the pinnacle, this pinnacle has been treated with H2SO4, what should be your answer? Okay, this is your rank deciding question kids. Question of the day based on Pinacol-pinacolone rearrangement. Pinacol-pinacolone. I have written Pinacolone. I don't think I have just written Pinacol only to understand to me. No, it's written Pinacol-pinacolone rearrangement. I have written. So this question is based on Pinacol-pinacolone rearrangement kids. So try to do it based on Pinacol-pinacolone rearrangement. So kids, this lecture has gone for 3 hours 16 minutes, right? But yes, I've seen your punctuality, I've seen your regularity, permanence, that really you are very, very good students, that for the whole time you were regular to this lecture, and this means a lot, because if you are hardworking, your success is waiting for you. And those who are just making wish for it and not doing proper efforts for it, they will never be able to get selected. Bye to all of you, my dear friends. Yeah, written. Thank you, RB Vichu by T. You are really thank you. Really thanks to everyone. And keep sharing, kids. Your Baba is really making so many efforts. See my efforts. How much efforts, how much dedication is there. So keep on sharing and be regular, everyone. It's each and everything will come from my notes only. I'm not saying from NCERT, because NCERT writes in between the lines the things which we are missing in NCERT. I'm going to give you, kids, number of things you must see, or you must have seen that number of things are missing in your NCERT. And I'm going to tell you each and everything, whatever the things which are given in NCERT and which are missing in your NCERT. I'm going to give you both the things. And really, for the last 24 years, whatever I'm telling to students that have been asked, because whatever is going to come in your examination, I keep on giving all those things. So God bless you, kids. Love you, kids. Bye to all of you. Bye, kids. Bye.